Here's something most guides won't tell you. The cheaper 3D printer might actually cost you more in the long run, while the expensive one could save you 100 hours of frustration. But it's not that simple, because the frustration itself might be the entire point. My name is Kazuki Tanaka, and I've spent hundreds of hours watching real teenagers use both of these machines in my fabrication lab. What I found challenges the usual advice you'll see online.
You're listening to the STEM Lab podcast. Quick note before we jump in. Everything you hear is researched, verified, and written by real people, in this case, me, but the voice you're hearing is AI generated. I want to be upfront about that. If you're a regular listener, thank you for being here. It genuinely means a lot. And if this is your first episode, welcome. We release new episodes every Monday, Wednesday, and Friday covering hands-on STEM tools, robotics kits, 3D printers, and learning aids that actually build real skills. Today, we're comparing two 3D printers that take completely different approaches to teaching teens digital fabrication. Let's jump in.
Let me start with the conclusion because I think you deserve that up front. If you want your teen to build genuine fabrication skills and you don't mind some troubleshooting along the way, the Creality Ender 3 V3 SE wins. But the Flashforge Adventurer 5M delivers faster learning without what I call the frustration tax. This is the Creality Ender 3 versus Flashforge Adventurer debate for teens, broken down with real workshop data, skill outcomes you can actually measure, and compatibility specs that matter for progressive learning. I've run both machines through hundreds of hours in my fabrication lab. I've watched dozens of teenagers interact with them, and I've tracked which one actually builds the capabilities that transfer to industry tools. Here's what you need to know. Let me give you a quick comparison of what we're looking at. The Ender 3 has a steep learning curve. It requires manual bed leveling, frequent calibration, and real troubleshooting skills. The Adventurer 5M is much gentler, with auto-leveling, an enclosed build chamber, and minimal setup. When it comes to what skills they actually build, the Ender 3 teaches manual calibration, G-code literacy, hardware troubleshooting, and material science basics. The Adventurer teaches CAD-to-print workflow, file preparation, and fast design iteration. Software-wise, the Ender 3 works with Cura and Prusa Slicer, which are industry-standard tools with full G-code control. The Adventurer uses FlashPrint, which is proprietary and Windows or macOS only, with limited third-party support. Build volumes are nearly identical, around 220 by 220 millimeters, though the Adventurer is slightly shorter on the vertical axis. The Ender 3 is fully open source with a massive modding community and cheap replacement parts, while the Adventurer uses proprietary components with a limited upgrade path. Cost-wise, the Ender 3 runs about $200 to $250, plus inevitable upgrades and a significant time investment. The Adventurer runs $400 to $500, but needs minimal additional costs. Now, let's talk about build quality and assembly because this is actually where learning starts. The Creality Ender 3 versus Flashforge Adventurer question for teens really begins at unboxing. The Ender 3 V3 SE arrives partially assembled. Your teen will spend 1 to 2 hours bolting the frame together, routing cables, and understanding how the machine actually works. I've watched this process with about 30 students. Half of them love it, treating it like a technical Lego project. The other half get frustrated and need adult intervention. Here's the reality. That assembly time is your first skill checkpoint. If your teen can follow the included instructions, manage an Allen key set, and troubleshoot a misaligned Z-axis rod, they're demonstrating spatial reasoning and mechanical aptitude. Those are real capabilities. But if they bail after 20 minutes and you finish the build, you've just bought them a tool they won't maintain. The Ender 3's open frame design means everything is visible and accessible. The print bed sits on dual Y-axis rails. The extruder runs on a single Z-axis lead screw. The hot end carriage rides on V-slot wheels along the X-axis gantry. I can point to any part and explain its function in 30 seconds. This transparency is pedagogically valuable. It demystifies the machine. The Flashforge Adventurer 5M ships nearly ready to print.
Unbox it, remove packaging materials, run the automated bed leveling routine, load filament, and print within 30 minutes. The enclosed build chamber hides most mechanical components behind sheet metal panels. This design prioritizes safety and ease of use over education about machine mechanics. When it comes to build quality, the Ender 3 uses stamped aluminum extrusions and plastic cable management clips that feel budget appropriate. I've seen the Bowden tube coupler pop loose during aggressive retractions. It's a $3 fix, but annoying mid-print. The print bed's magnetic spring steel sheet scratches easily, but costs around $15 to replace. After 200 hours in my shop, the machine still prints accurately, but it looks worn. The Adventurer 5M's enclosed chassis feels substantially more robust. The print bed uses a textured PEI sheet bonded to a rigid aluminum plate. It's harder to damage and easier to clean. The direct drive extruder is fully enclosed within the print head assembly. The machine weighs about 15 pounds more than the Ender 3, and that mass translates to reduced vibration during high-speed prints. Here's a design flaw nobody mentions. The Ender 3's cooling shroud directs airflow poorly on overhangs steeper than 60 degrees. You'll see curling on bridging features unless you print a replacement shroud from Thingiverse, which means your team needs to successfully complete their first print before they can fix the printer's inherent weakness. That's frustrating circular logic for beginners. The Adventurer 5M's cooling is better engineered, but the proprietary filament cartridge system is a trap. Flashforge claims it's for convenience, but it locks you into their filament ecosystem at around $25 to $30 per kilogram versus $15 to $20 for generic PLA spools. You can hack standard filament to work, but it voids the warranty and defeats the plug-and-play premise. Moving on to the software ecosystem and learning path integration, this is where the Creality Ender 3 versus Flashforge Adventurer comparison for teens gets strategically important.
The Ender 3 works with Ultimaker Cura, the industry-standard slicing software used in professional fabrication labs, engineering firms, and university makerspaces. When your teen learns Cura, they're building transferable skills. I use Cura in my professional work. The Prusa i3 MK4 printers at the University of Washington's Co-Motion Makerspace all run Cura. Learning this software has career value. Cura exposes every parameter: layer height, print speed, retraction distance, cooling fan curves, support generation algorithms, infill density, top and bottom layer count, wall line count, Z-hop height, combing mode, ironing settings, adaptive layer height. That's simultaneously Cura's strength and weakness. You can tune prints to perfection, but first you need to understand what retraction distance means and why it matters. I spent 6 months teaching teenagers to use Cura. Here's the skill progression I observed. In weeks 1 and 2, they load a pre-sliced file from Thingiverse, send it to the printer, and pray it works. Success rate is about 60%. Weeks 3 and 4, they open STL files in Cura, learn basic orientation, discover support structures, and understand bed adhesion settings. Success rate jumps to 80%. Weeks 5 through 8, they start adjusting layer height and infill based on part requirements and troubleshoot failed prints by reviewing G-code preview. Success rate hits 85 to 90%. By month 3 and beyond, they're doing custom support placement, multiple materials in single prints, and designing parts specifically for FDM constraints. Success rate climbs above 95%. That progression requires sustained engagement. If your teen prints something once every 3 weeks, they'll never climb that curve. The Flashforge Adventurer 5M uses FlashPrint, a simplified slicing application that hides most complexity. You select print quality, fast, normal, or high, choose support type, and click Print. FlashPrint makes reasonable default decisions about temperatures, speeds, and cooling. For someone who wants to design a mounting bracket and see it physically materialize in 90 minutes, FlashPrint is perfect. But here's what I've learned from watching learners. Flashprint's simplicity becomes a skill ceiling around month 6. When your teen wants to print flexible TPU, experiment with variable layer heights, or optimize support structures for complex geometry, Flashprint doesn't expose those controls. You can't export G-code to analyze toolpaths. You can't write custom start and end scripts.
That said, Flashprint integrates with Tinkercad and Fusion 360 through Flash Cloud, Flashforge's cloud-based print management system. Design something in Tinkercad, click Export to Flashprint, and the file transfers automatically. This streamlined workflow reduces friction in the design, iterate, test cycle, which is pedagogically valuable for younger teens, 13 to 14 years old, who'd otherwise get discouraged by file management. Here's the software compatibility reality check. The Ender 3 V3 SE works with Cura, Prusa Slicer, Simplify 3D, Octoprint, Clipper firmware mods, full G-code editing. You can control everything. The Adventurer 5M is locked to Flashprint or Flash Cloud unless you're willing to hack profiles in Cura, which breaks auto-leveling and material detection features. The Ender 3 runs on standard open-source firmware called Marlin, which means your team can reflash the motherboard, install custom features, and learn how firmware actually controls hardware. That's the kind of low-level technical literacy that transfers to robotics, CNC machining, and other digitally controlled tools. If your team is already comfortable with Arduino IDE and wants to understand embedded systems, the Ender 3 is a working learning platform. The Adventurer 5M's proprietary firmware is a black box. You can't modify it, you can't inspect it. That's a non-issue if you just want to print parts, but it eliminates an entire learning dimension. Let's talk about print quality, speed, and real-world performance. I've printed the same benchmark test suite on both machines. Detailed miniatures, functional mechanical parts with tight tolerances, large flat panels prone to warping, overhanging geometry, and bridging tests. For layer adhesion and surface finish, the Ender 3 V3 SE produces excellent results when properly calibrated. I'm talking visible layer lines below 0.2 millimeters, crisp corners, minimal stringing on properly tuned retraction. But achieving that quality requires dialing in your specific filament. Every brand has slightly different flow characteristics and thermal properties. The Adventurer 5M's direct drive extruder produces slightly better surface finish out of the box, especially on materials like PETG that are sensitive to retraction tuning. The enclosed build chamber maintains consistent ambient temperature, reducing warping on large prints. I printed a 180mm by 180mm flat baseplate on both machines. The Ender 3 version warped about 1.5mm at the corners, despite using a brim and bed adhesive. The Adventurer 5M print stayed flat. When it comes to speed, this is where newer FDM technology shows up. The Ender 3 V3 SE prints at practical speeds of 50 to 80 millimeters per second for quality work. Push it to 100 millimeters per second and you'll see quality degradation, ringing, also called ghosting on sharp corners, reduced layer adhesion, and potential extruder skipping. It's a 2024 generation design running on motion control systems that haven't fundamentally changed since 2018. The Adventurer 5M prints at practical speeds of 80 to 120 millimeters per second without significant quality loss. The beefier frame and direct drive extruder handle acceleration better. A complex print that takes 6 hours on the Ender 3 finishes in about 4.5 hours on the Adventurer 5M. That faster iteration speed matters when your teen is debugging a design through multiple prototypes. First layer adhesion is where this comparison gets annoying for the Ender 3. Despite the V3 SE including a CR Touch automatic bed leveling sensor, I still need to manually adjust the bed leveling about once every 10 to 15 prints. The springs under the bed lose tension over time. The print surface isn't perfectly flat. It has a slight bowl shape that requires mesh bed leveling compensation. The Adventurer 5M's auto-leveling works consistently. Load filament, start print, walk away. I haven't manually touched bed leveling in over 150 prints. That reliability is worth real money in saved frustration hours. Material compatibility is similar on both. The Ender 3 V3 SE handles PLA, PETG, TPU with modifications, and ABS if you add an enclosure mod. Maximum nozzle temperature of 260 degrees Celsius limits you to standard FDM materials. The Adventurer 5M handles PLA, PETG, TPU, and ABS. The enclosed chamber helps. Same practical thermal range, but better thermal management. Neither machine handles engineering-grade materials like polycarbonate, nylon, or carbon fiber composites without significant modifications. For teen projects, that limitation doesn't matter. Standard PLA covers 95% of use cases. Here's the reliability truth. I tracked failure rates over 50 prints on each machine. The Ender 3 had 8 failures, 6 due to first layer adhesion issues, 1 extruder clog, 1 mid-print bed leveling drift. The Adventurer 5M had 2 failures, both from filament tangles on poorly wound spools. That 16% versus 4% failure rate represents real learning friction. Now let's cover the lab specs: power, safety, and workshop integration.
For power requirements, the Ender 3 V3 SE has a 350-watt max power draw with a standard 120-volt AC plug. You don't need a UPS, but it's recommended for mid-print power protection. The Adventurer 5M has a 280-watt max draw, also standard 120-volt AC, and it's slightly more efficient due to better insulation. Both machines will run fine on a standard bedroom outlet. Neither requires dedicated 20-amp circuits like some resin printers or laser cutters. Noise levels matter. The Ender 3 generates about 55 to 60 decibels during printing, roughly equivalent to normal conversation volume, but with an annoying high-frequency stepper motor whine. The cooling fan runs constantly during prints. I wouldn't want this running in a shared bedroom overnight. The Adventurer 5M runs quieter at about 45 to 50 decibels thanks to the enclosed chassis and better stepper motor drivers. The sound profile is lower frequency and less intrusive. It's feasible to run this in a bedroom workspace during homework hours. For safety considerations, the Ender 3's open frame design means the hot end, heated bed, and moving parts are fully exposed. I've watched teenagers brush against the 200 degrees Celsius hot end, touch the print mid-operation, and catch clothing in the moving Z-axis lead screw. This is a supervised tool for 13 to 14-year-olds, gradually moving toward independent use at 15 to 16. The Adventurer 5M's enclosed design provides passive safety. You'd have to deliberately open the door to access hot components. The machine pauses automatically if the door opens mid-print. This design is appropriate for younger independent use, 13 and up, with initial adult supervision. Both machines produce ultrafine particles and volatile organic compounds when printing, even with PLA. The Ender 3 requires adequate room ventilation. I recommend printing near an open window or using a HEPA filter with activated carbon. The Adventurer 5M includes an internal HEPA filtration system that captures most particulates, but I still recommend supplemental room ventilation for extended printing sessions. When it comes to expandability and upgrade path, the Ender 3 has a massive aftermarket ecosystem. You can upgrade to an all-metal hot end for higher temperature materials, a direct drive extruder for flexible filaments, linear rails replacing V-slot wheels for better precision, a 32-bit silent motherboard for quieter operation, or dual Z-axis for improved bed tramming. Those upgrades transform the machine but require mechanical skill and troubleshooting ability. This upgrade path is a feature if your teen wants to learn hardware modification. It's a bug if they just want to print parts. The Adventurer 5M offers minimal expandability. The print head is a proprietary assembly. The motherboard isn't user accessible. You can't swap nozzles without voiding the warranty. This is an appliance, not a platform. For longevity and total cost over a 3-year learning timeline, here's what I'd budget. For the Ender 3, $220 for the printer, plus $100 in replacement parts like nozzles, couplers, build plates, and fans. plus $80 in upgrades like a metal extruder, better bed springs, and Capricorn Bowden tube, plus about 150 hours of tinkering time. That's around $400 cash plus significant time investment. For the Adventurer 5M, $450 for the printer, plus $40 in replacement build plates, plus minimal maintenance time. That's around $490 total. Space footprint is similar. Both machines occupy roughly 17 by 17 by 20 inches of desk space. The Ender 3 needs additional clearance behind the machine for Bowden tube movement and front access for bed removal. The Adventurer 5M's enclosed design allows placement closer to walls. Let's talk about progressive learning outcomes and skills that transfer. This is what I care about most. Which machine builds capabilities that apply to other STEM domains? After 14 to 18 months of active use, here are the Ender 3 skill outcomes. Mechanical troubleshooting, diagnosing why the extruder is skipping, why prints aren't sticking, why layers are delaminating. Material science basics, understanding glass transition temperature, crystallinity, moisture absorption, thermal expansion coefficients. G-code literacy, reading toolpath previews, understanding feed rates and temperatures, recognizing when a print will fail before wasting filament. Hardware modification, installing upgrades, reflashing firmware, tuning stepper current, adjusting acceleration limits. Systematic debugging, changing one variable at a time, documenting results, building an internal knowledge base of what affects what. These are engineering habits of mind. They transfer directly to robotics, CNC programming, automotive diagnostics, and electronics troubleshooting. If your teen already works with Arduino robotics kits or is interested in embedded systems, the Ender 3 integrates naturally into that learning path. After the same 14 to 18 months with the Adventurer 5M, here are the skill outcomes. Rapid design iteration, moving from idea to physical prototype in hours, not days. CAD to manufacturing workflow, understanding file formats, scale, orientation, support requirements. Functional design thinking, designing parts that account for FDM constraints like minimum wall thickness, overhang angles, and support removal. Project completion focus, prioritizing done over perfect, shipping working prototypes instead of optimizing endlessly. Tool integration, combining 3D printing with other fabrication methods, like laser cutting, hand tools, and assembly.
These are product development habits. They transfer to industrial design, mechanical engineering, startup prototyping, and maker entrepreneurship. If your teen wants to design custom parts for robotics competitions or science fair projects, the Adventurer 5M keeps them focused on outcomes rather than printer maintenance. Neither machine teaches design software. You need to pair either printer with Tinkercad or Fusion 360 training separately. But the Ender 3 rewards technical depth while the Adventurer 5M rewards creative output. Choose based on your teen's existing interests and patience threshold. So who should choose the Creality Ender 3 V3 SE? Buy the Ender 3 if your teen already demonstrates mechanical aptitude through Lego Technic, model building, or automotive interest. If they enjoy troubleshooting and don't get discouraged by failed prints. If they want to understand how things work at a hardware level. If they plan to integrate 3D printing with Arduino projects, robot building, or other fabrication tools. If they have 3 to 5 hours per week to invest in learning, maintenance, and optimization. If they respond well to challenge-based learning and find satisfaction in incremental improvement. The Ender 3 is a teaching platform disguised as a printer. You're not buying a tool, you're buying a curriculum in mechanical systems, material science, and troubleshooting methodology. The frustration tax is real, but so are the capabilities it builds. Who should choose the Flashforge Adventurer 5M? Buy the Adventurer 5M if your teen wants to use 3D printing as a tool for other projects, props, enclosures, mechanical assemblies, rather than as a learning focus itself. If they get frustrated by failed prints and need reliability to maintain engagement. If they have limited time and want to prioritize design skills over hardware tinkering. If they work on school projects with hard deadlines where printer downtime creates real problems.
If they're 13 to 14 years old and need a safer, more supervised-friendly enclosed design. If they value fast iteration and design output over mechanical literacy. The Adventurer 5M is a production tool for teenage makers. You're buying capability and time. Fewer failed prints, faster results, less maintenance overhead. The trade-off is reduced learning about the machine itself, but if that's not your priority, it's a worthy trade. Let me address some frequently asked questions. Can a 13-year-old operate the Creality Ender 3 independently? With initial supervision and training, yes. Most 13-year-olds can operate the Ender 3 independently within 3 to 4 weeks of guided use. The machine requires understanding hot surfaces, a 200 degrees Celsius or hotter hot end, and a 60-degree bed, managing filament loading, troubleshooting first layer adhesion, and recognizing when prints are failing. Independent operation means they can start a print, monitor progress, recognize problems, and either fix them or know when to ask for help. The open frame design requires more safety awareness than enclosed printers, but teenagers who handle soldering irons, power tools, or kitchen appliances with proper training can safely operate the Ender 3. What's the actual filament cost difference between the two printers? Standard PLA filament for the Ender 3 costs around $15 to $20 per kilogram from brands like Hatchbox, Eson, or Overture, giving you roughly 330 meters of 1.75 millimeter filament. The Adventurer 5M technically accepts the same generic filament at the same price, but Flashforge strongly recommends their proprietary cartridges at around $25 to $30 per kilogram for warranty coverage and optimal performance. Over a year of moderate use, 3 to 4 kilograms of filament, you'd spend around $60 to $80 with the Ender 3 versus around $90 to $120 with Adventurer 5M proprietary filament, though many users successfully run generic filament in the Adventurer by manually loading spools and bypassing the cartridge system. Do these printers work with school CAD programs like Fusion 360 and Tinkercad? Both printers work with any CAD software that exports STL or OBJ files. Fusion 360, Tinkercad, Onshape, SolidWorks, Blender, FreeCAD, they all output compatible formats. The workflow is design your part in CAD software, export as STL, import that STL into your slicing software, Cura for Ender 3, FlashPrint for Adventurer 5M, configure print settings, then generate the G-code file that the printer executes. The Adventurer 5M has slight workflow advantages through Flash Cloud integration that lets you send files directly from Tinkercad to the printer without manually downloading and re-uploading. But the Ender 3 works perfectly fine with a standard save and import workflow that takes about 15 seconds longer per print. Here's the bottom line. The Creality Ender 3 versus Flashforge Adventurer decision for teens comes down to learning goals, not printer specs. The Ender 3 builds mechanical literacy and troubleshooting resilience. It's the better choice for teens who want to understand fabrication at a systems level, plan to modify and upgrade hardware, or already demonstrate patience with technical challenges. You're paying around $200 to $300 total for a hands-on engineering education that happens to produce plastic parts. The Adventurer 5M builds design iteration speed and project completion habits. It's the better choice for teens who want to use 3D printing as a tool for other creative or functional projects, need reliability for school deadlines, or benefit from the reduced frustration and supervision requirements of an enclosed, automated system. You're paying around $450 to $500 for a capable production tool that lets them focus on design rather than machine operation. I keep both in my shop. The Ender 3 teaches, the Adventurer 5M produces. Choose based on whether your teen wants to learn the tool or use the tool. Both are legitimate paths into digital fabrication. That wraps up this episode of the STEM Lab podcast. Thanks for listening. New episodes come out every Monday, Wednesday, and Friday, so hit subscribe or follow if you haven't already. That way, you'll get notified the second a new episode drops. And if you found this helpful, I'd really appreciate it if you'd leave a 5-star rating and a quick review. It sounds like a small thing, but it genuinely makes a difference. It's how other people find the show, and it helps me know what's landing and what's not. Thanks again, and I'll see you in the next one.